Hi everyone and welcome back to the course. In this video we will talk about Kubernetes. So the advantage of using containers to run a group of software applications is already established using Docker. However, in a production environment, managing and running containers is important to minimize the downtime of the service. And this is where we're using Kubernetes. Kubernetes is used to automatically start a new container if a container fails. So Kubernetes follows master-slave architecture and it is also known as K8s. This is the most popular container orchestration engine on the market. It is open source for applications executing in software containers, automating the deployment, scalability, and management of the distributed applications. So Kubernetes groups the containers into logical groups called pods, which represent the basic unit of the manager that can be distributed in the cluster by the Kubernetes process. One pod can have a set of containers that share the same storage and a single IP address. So the Kubernetes, as I mentioned, has a master-slave architecture, and so the master container, as you can see on the figure right here, control and schedules all the activities of the container, while the workers right here, as you can see, are actually the nodes. And here is where the containers are executed. You can have multiple nodes for one Kubernetes master. So the ability to have multiple nodes or orchestrated containers makes Kubernetes a perfect addition to the microservices-based applications. So the master container right here acts as a central control level in the cluster, and it's composed of four basic elements that allow coordination within the cluster and to distribute tasks. So those are the IP server, which is responsible for launching all automations in API server by using RESTful API services. The server acts as a central management point in the cluster. Then we have the etcd, which is an open source key value store and can be considered a Kubernetes cluster memory. It's been developed especially for distributed systems to store configuration data. Then you have the scheduler, which distributes the pods in the cluster, so it finds out how many resources a pod needs and basically adjusts them within the resources available for each node in the cluster. And finally, we have the controller manager right here, which is a service of the Kubernetes master that manages the status of the cluster and executes the routine tasks directing the orchestration. So the main function is to ensure that the cluster state corresponds to the state that was previously defined as an objective. So while the master is responsible for the orchestration, the distributed pods in the cluster are running different nodes called workers. To do this, each node needs to run a container engine compatible with the container tool like Docker or Podman. So you can imagine that basically Kubernetes runs the master and have multiple containers as Docker, or actually a container tools as Docker, which contain multiple containers. So one Kubernetes could have a few Dockers or Podmans or any other such tool. And so let's talk about what each Kubernetes node includes. So the first one is a kubelet, and this is used to direct and manage the node. This process maintains the communication and ensures that the information is sent to the worker nodes. The agent receives the requests and supervises their execution in each node. Then you have here the kube proxy, which is a proxy service that is executed in each Kubernetes node to serve the requests that come from worker nodes and provide services to the users of the container application such as Docker. And as you can see, these proxies, they go directly to the users right here, and this is how the services are provided. So in order to understand Kubernetes better, let's talk about some of the key terms using Kubernetes. So the advantages of using containers to run in a group software application are quite a lot. And Kubernetes extends that by creating the ability for us to have multiple container application tools that consist of multiple containers. And here I bring you some of the key capabilities that Kubernetes can provide. The first one is the service discovery and the load balancing. And this is quite important point. Kubernetes can expose a container using its own domain name and IP address. It is also capable for balancing the workload and distributing the traffic in a way that the deployment is quite stable. The next key point is that Kubernetes provides storage orchestration. It allows you to automatically mount a storage system of your choice, such as local storages, public cloud, and any other type of computing providers. It allows you to describe the desired state of your payload containers, and you can change the current state of your containers to desired state. For example, you can automate Kubernetes to create new containers for deployment, remove existing containers, and adopt all of its resources into a new container. Also, Kubernetes can actually restart the containers that fail and is replacing the containers that are not responding within the cluster. Then you have the resource management. As you can see, Kubernetes is actually all about management and allows you to specify how much CPU and memory or RAM each of the container needs. So Kubernetes can actually take better decisions than the developers to manage container resources when containers have specified resource requests. It can also provide secret and configuration management. It allows you to store and manage information related to the configuration of the containers, as well as the most sensitive information like password, keys, and tokens. This sensitive information and the configuration parameters can be updated without the need to reconstruct the container images and without the need to open the sensitive information. So there are also some additional terms that you need to understand in order to get better understanding of Kubernetes. So firstly, we already talked about cluster, and cluster is a physical or virtual resource and storage resources used by Kubernetes where pods are deployed, managed, and replaced. So cluster is basically a storage location. Then you have the pods that are a smaller unit that can include one or more containers. In many cases, a pod is composed of single container, but its ability to accumulate several containers very close to each other is quite powerful feature. Then you have the replication controller, which is a Kubernetes mechanism to ensure that a pod has raised a certain number of replicas. For example, the replication container raises more replicas if you need more and kills them if you need less. It raises new replicas to keep the number defined if any of them fails or dies. Then the services define how to access a group of pods and allows access to containers with a unique domain name server and IP address. And finally, the labels are used to organize and select a group of objects in pairs of key and values. So a pod can contain one or more containers running at the same time, and it is basically the unit that the Kubernetes manages. So there are several advantages that Kubernetes brings to the management of containers as pods. So before starting with the Kubernetes configuration, you should understand that there are four key concepts that you need to know. Those are the Kubernetes driver, which acts as a node from which pods, replica controllers, and services of the Kubernetes environment are deployed and managed. And later on, I will show you how you can create a Kubernetes driver. Then the Kubernetes nodes provide environment in which containers can be executed. Later, we'll run the command kubeproxy in order to start all the containers within a node. Then we have the kubectl command, which is used to do the Kubernetes management into the master node. So with the kubectl, we can create, obtain, describe, or eliminate any resources that Kubernetes manages, such as pods, replica controllers, and services. And finally, the resource files YAML and JSON are used to manage and create pods. You can install and deploy Kubernetes from kubernetes.io, but that we will do in the next sections where we will talk specifically about Kubernetes. So that will be everything for now, guys. Thank you very much for watching, and in the next section I will teach you how to manage your containers and Docker images in Docker.